Hello everyone, this is another video on trying to solve Griffith, where we'll be solving more questions on it. And we'll trying to solve here. These are some like standard good questions, and it's not like it's easy and you just put the values and get the answer. No, these are very descriptive and derivation type questions, which don't usually come in exam, but while solving it, uh, we will like encounter some steps or concepts that will help us doing um, less like less derivative questions. Okay, yeah. So let's do. These are basically this is the third chapter of Griffith book, like that is special techniques. And here it's about uniqueness theorem, like image charges, okay, method of images. These two will be the more main focus in this video. As you have seen, we have properly done trying to solve Griffith from the video one. Like beginning, we solved electrostatics, okay, charges, potential, electric field. Then potential was also there. Hmm. Then also we did a Warden and then capacitance. So we're gradually going on it. Hmm. Capacitance. So it's not like I'm just doing it randomly. You can see in the first video the questions were like this. Now it's 3.1. So we're gradually trying to cover Griffith. Okay. And the thing is, this won't be done overnight. Okay? It will take time. You have to do it consistently on a regular basis. You just don't think that I will solve it everything on one day or 1 week. Okay, and it's also not good to solve it in 1 week, because if you solve it in 1 week, the week after week, like the after 2 weeks, you will forget it. So it's better to keep solving it 3 4 questions every day for a longer period of time, so that you will keep in touch with all the concepts. Yeah, so it's better not to solve everything at one go. Make it keep it slow, keep it steady, and that will help. Okay, so so that the potential is constant inside an enclosure completely surrounded by conducting material, provided there is no charge within the enclosure. First, our purpose is to read the question 3 times. 3 times, whether you understand it or not, just read it 3 times, so that the potential is constant. Potential is constant. The second or third time you only start writing. First time you just read. Inside an enclosure completely surrounded by conducting material. This is a conducting material. Provided there is no charge within the enclosure. There is no charge. Q is enclosed 0. So what do we have to find? Potential is constant. Okay. Potential is constant inside it. Okay. For example, potential is some constant V naught at the wall of the cavity. Okay. This is suppose a cavity. Hmm. And so potential inside is a function which satisfies Laplace equation. What is Laplace equation? Do you know Laplace equation? And has the constant value at the boundary. See, at the boundary, this is V naught, but like constant value at the inside satisfy Laplace equation. Okay, so so what can we conclude from that is the field inside the empty cavity is 0. Okay, field inside is 0. This is from what? This is from uniqueness theorem. Okay, I hope you have studied uniqueness theorem. All right, and yeah. What does it say? It say it satisfies Laplace equation. Uniqueness theorem satisfies Laplace equation, and it has the correct values on the boundaries. All right. Hmm. So you will see the power of this argument when we come to the method of images, which is the next one. Okay. Okay. See, for example, we will take two potentials here. For example, that is del square V1 is equal to how much it will be? Minus rho by epsilon naught. This is your what? Which equation? Poisson's equation. Okay. Del square V2, another region, del square V2 will be also minus rho by epsilon naught. Okay. So what is the difference? What is your Laplace equation? Like V3 is V1 minus V2. Okay. So like it satisfies your Laplace equation. Satisfies Laplace equation. Okay. So if we do like V3 is equal to V1 minus V2, I can write it as V3 V1 minus V2. So del square V3 is equal to del square V1 minus del square V2. So del square V1 is minus rho by epsilon naught minus rho by epsilon naught. So this becomes minus rho by epsilon naught plus rho by epsilon, that is 0. So del square V3 is 0, which again, as you see, this is your Laplace equation, isn't it? Laplace equation is a form of Poisson's equation. Laplace equation is what? Del square V is equal to 0. So we got, so this is your Laplace equation. Laplace equation is satisfied. Okay. So if Laplace equation is satisfied, then what we can say? We can say V1 is equal to V2. Okay. So it has what? Potential has constant values at the boundaries. The boundary we took 2 points. Constant values at the boundaries. Okay, which is the question. If you see the question, so that potential is constant inside and enclosure completely surrounded. So it is constant. We proved it. V1 is equal to V2. Okay. Application of uniqueness theorem. Right. I hope you understood. You just, if you couldn't understand, then you just go and go through uniqueness theorem. All right, that will really help. Next question. A point charge is situated at a distance a from the center of a grounded conducting sphere. Yeah, this is your method of images. Okay, sphere of radius r. Find the potential outside the sphere. Yeah, find and the potential outside the sphere. Okay, this is an image problem. A distance a from a center of a grounded conducting sphere. Suppose this is your x, y, z. Suppose this is your grounded conducting sphere V0 for this sphere. So at a distance a, okay, at a distance a, so yeah, at a distance a, right? Sphere of radius r. Okay, wait, sphere. No, sorry, my bad. Okay, the sphere is given. The sphere is like this. Center is radius r at a distance a. Okay, we have to find at a distance a. This is a grounded conducting sphere V0. Hmm. So how do we calculate it? So you can draw the diagram also like this. Charge is here q. Image charge will be q dash here. Okay. Center. Uh, there's your this is the point. Potential outside the sphere. So here, this is the point where we have to calculate the potential. So r dash. Sorry. Suppose this is x dash. X dash. This is x. Q dash. This is your theta. This is b. This is a. All right. So if we see from a formula, we know q dash is how much actually r by a. Okay, radius of the sphere divided by a distance from the point distance of the charge from the center a into q into the charge q. All right, into the charge q. Huh. And this b distance will be this b distance is your r square by a. These two formulas you have to remember. Okay, these two formulas you have to remember. So now, so potential of the configuration, how, because there are two charges, this q dash, this q. At the point, this is the point P where we have to calculate the potential. So potential will be 1 by 4 pi epsilon naught q by r plus q dash by r dash or x dash. Sorry, q by x divided by q dash by x dash. Okay, that is the potential. Okay, where your x and x dash are the distances from q and q dash respectively. Q and q dash. Okay, now that potential vanishes at all points on the sphere. Why? Because this is grounded. Okay, this is grounded. All right. So now if you calculate the force between them, okay, the force between the charges, force will be how much? 1 by 4 pi epsilon naught q dash by how much? Q dash by this distance will be how much? A minus b. This is b. This is a minus b. So a minus b whole square. Okay, a minus b whole square, isn't it? Yeah. Now we can do what? In place of q dash, we'll put this. In place of b, we'll put this. Okay, let's do it. So I will write, if I write again f value, f is equal to 1 by 4 pi epsilon naught q dash by a minus b whole square. Q dash is your r square by a into q. So minus r by a, my bad, into q, and b is equal to r square by a. Is that all right? B is equal to r square by a. So I will put it here. 1 by 4 pi epsilon naught q into q dash is how much? Minus r by a into q divided by a minus r square by a whole square. So 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught minus goes out. So this is q square r by a whole divided by a square minus r square divided by a square, because this is a square. Yeah. So minus 1 by 4 pi epsilon naught, 4 pi epsilon naught q square r by a into a square divided by a square minus r square whole square. Okay. So minus 1 by 4 pi epsilon naught, it's a cancelled, q square r a divided by a square minus r square whole square. Is that correct? Okay. Yeah. So this is a force. Okay. All right. Is it clear? Hmm. So actually, we had to find the potential. So I calculated both potential to this one, potential and also the force. Okay. Yeah. So yeah, no problem. This is a generalized question. This is not a direct, like it won't come, but just know how to derive these things. Okay. Yeah. Next question. Find the force on uh, the force on the okay. There's a diagram I haven't given. This distance B. This distance is 3D. Okay. Find the force on charge plus Q in the figure. Yeah. Try this question. This is a grounded conducting sphere. Sorry, a surface. XY. So what you have to do, we have to draw an image charges. So for minus 2q, the image charge will be plus 2q at a distance of d. For plus q, the image charge will be minus q at a distance of 3d. Okay. So you have to find the force on plus q. So there are how many charges? One, two, three. So because of all the charges, we will find the force. So for example, this is okay. One, two, three, four. Four charges, right? So we have to find the force on one. Okay. So force on one because of two will be what? What is the distance between them? 2d. So 1 by 4 pi epsilon naught q into 2q divided by 2d whole square. Yeah. Yeah. All right. And the direction will be what? Direction will be towards minus 2q. Okay. So that is minus z cap. Okay. Now f because of 3, now let's calculate because of 3, 1 by 4 pi epsilon naught q into 2q divided by what is the distance between them? This is 3d, this is d, 4d square. Hmm. What is the like on charge q? What is the direction of force? Away, because it's a positive charge. Now f 1 4 1 by 4 pi epsilon naught q into q. We'll only take the magnitude. Okay, divided by what is the distance? 3d into 3d, that is 9d square. Okay, and the direction will be towards minus q because it's negative, that's minus z cap. Okay, and this is what 1 by 4 pi epsilon naught, if we simplify it, 2q square by 4d square minus z cap, 1 by 4 pi epsilon naught 2q square by 16d square z cap, 1 by 4 pi epsilon naught q square by 4d square minus z cap. So we'll just simply add them now because everything is in proper like directions and all. So net force would be F is equal to F total on 1, F12 plus F13 plus F14. Okay, so that will be 1 by 4 pi epsilon naught 2q square by 4d square. That means q square by 2d square minus z cap plus 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught q square by 8d square z cap plus 1 by 4 pi epsilon naught q square by 4d square minus z cap. Okay, so 1 by 4 pi epsilon naught q square by d square. This is, I can, let's see, z cap I can take common also. Z cap, this is minus 1 by 2 plus 1 by 8 minus 1 by 4 by 4 pi epsilon naught q square by d square z cap 8. So minus 4 plus 1 minus 2 minus 6 plus 1 minus 5 by 8. So the answer is 5 by, okay, 1 by 4 pi epsilon naught. Okay, 5 q square by 8 d square minus z cap, because minus 5 by 8 came from it. So minus z cap. Is that clear? Is that clear? Is that clear, or did I do any mistake? Please let me know if I did any mistake. Oh, this is 9d square. My bad. Sorry. This is 9. Shit. This is 9. This is 9. Okay. Wait. If you do everything correct, then at the end, if you do like this, then gone. That's all the hard work will be gone. Okay. So this will be 1 by 4 pi epsilon naught q square by d square z cap. That will be 72 minus 36 plus 18 minus 8. 1 by 4 pi epsilon naught q square by d square z cap minus 18 minus this is minus 26 by 72. Okay. Okay, again I did a mistake here. This is 9. This is sorry. It's minus 27 minus 44 plus 9. Wait, just give me a second. Oh, what have I done? Yeah, I'm doing mistake again and again. See, this is 3D. This is 3D. So this is a whole 60, right? So this should be 60 square, no? 36D square. Simple mistake. Can. So this is your 1 by 36. So this is your 72 uh, minus 36 plus 9 plus 2. I hope this is at least correct. This is minus. Okay. Okay, now I think it will be correct. 29 by 72. 1 by 4 pi epsilon naught minus 29 minus is there. Q 29 q square. 29 q square by d square z cap. 72 z d square z cap. That is the final answer for this. I hope you all understood this. I made some silly mistakes. Like this silly mistakes happen a lot. So we have to be careful about it. Okay, we'll move to the next question now. Using law of cosines, so that equation 3.17 can be written as follows. Equation 3.17 can be written as follows. V r theta is equal to 1 by over epsilon this. Okay. So how to solve this question? Actually, this one is, I have to know the equation 3.17, which I don't have. Okay, let's skip this question. Okay. An example. Okay, again example 3.2. We assume that the conducting sphere is grounded. Okay, but the addition of second image charge, the same basic model to handle the case of the sphere at any potential V. What charge should we use? Where should we put it? Find the force of attraction between a point charge Q and a neutral conducting sphere. We assumed that the conducting sphere was grounded, but with the addition of a second image charge, the same basic model will handle the case of a sphere at any potential V naught. What charge should we use and where should we put it? Find the force of attraction between a point charge Q and a neutral conducting sphere. Okay. We assume that the conducting sphere was grounded, but with the addition of a second image charge, the same basic model will handle the case of a sphere at any potential V naught. And what charge should you use and where should you put it? Find the force of attraction between a point charge Q and a neutral conducting sphere. Okay. So, for example, this is your sphere. Place a second image charge Q double dash. Okay, at the center of the sphere. Okay. This will not alter the fact that sphere is what equipotential, right? But it will what? It will increase the potential from zero to something else, like for example V naught. Where V naught will be what? 1 by 4 pi epsilon naught Q double dash by radius is R, right? Yeah. So I can write Q double dash is equal to 4 pi epsilon naught V naught into R. Okay. At the what? At the center of sphere. At the center of sphere. Right? Now, see, this is your Q dash. There was another charge Q dash, sorry, Q dash here, and this is the original charge Q, right? So, we knew that now, for example, this is your distance a minus b, right? The distance was here a minus b, and the center from center the distance was q, if you remember. Yeah. So this is like this. So now, if we and for the like the sphere to be neutral, okay, and the sphere to be neutral, what should we do? Because this is a neutral conducting sphere. So what should be the thing? The charges inside must be adding to zero, right? Right? Yeah. So now the force of attraction between a point charge q and a neutral conducting sphere. So the force of attraction is 1 by 4 pi epsilon naught q, okay, q into q double dash by a square, right, plus 1 by 4 pi epsilon naught q into q dash by a minus b whole square. Is that all right? Okay. If we simplify it a bit, it will be, uh, if I write it again, um, how can I write it again? See, your q dash plus q double dash is equal to 0, right? So q double dash, I can write it as minus q dash, isn't it? Right? So the expression changes to 1 by 4 pi epsilon naught. I will write it again otherwise. Q double dash by a square plus 1 by 4 pi epsilon naught q q dash by a minus b whole square. So in place of q double dash, I will put, okay, let's take this minus 1 by 4 pi epsilon out. Q into minus q dash divided by a square plus q dash divided by a minus b whole square. Yeah. Now what will I do? 1 by 4 pi epsilon naught. Um, let's uh, let's take q dash out. Q dash out. So minus 1 by a square plus 1 by a minus b whole square. Is that all right? Yeah. Now we just have to simplify it. Now we just have to simplify it. But if we remember, q dash is how much in a conducting sphere? Minus r by a into q, right? If you remember, minus r by a by into q. Hmm. And your b is how much? B is how much? R square by a. Yeah. So we'll just put it here. So 1 by 4 pi epsilon naught q dash. Sorry, q dash is minus a 1 minus r by a q, minus 1 by a square plus 1 by a minus r square by a whole square. So minus r q square by 4 pi epsilon naught a. This one is minus 1 by a square plus a square minus r square whole square, and a square goes up. Okay. So minus r q square by 4 pi epsilon naught a. If you take the LCM, a square whole into a square minus r square whole square, that will be is minus r a square minus r square whole square minus plus a fourth. Okay. Yeah. Yeah, plus a fourth, and a fourth will be cancelled out because of that minus there. So that will be minus, like, so 2 a square r square minus r fourth divided by a square whole into a square minus r square also. So this will be the expression, right? This will be the expression. Yeah. Otherwise, you can take r square from here, a square from here. You can write it as minus q by 4 pi epsilon naught rq by aq. That means r by a whole cube, and 2a, or 2a minus 2a square minus r square divided by a square minus r square whole square. Okay. Yeah. So this is your f. Okay. So this is your force. Yeah. This is how you calculate this force between the, like, the conducting sphere and the charge. Hmm. So these are a bit lengthy questions, and you should be able to solve it, because this way only you can solve good questions. Numerical questions, so anyone can solve. You can just put the value in the formula and all, but you should be able to solve these questions also. Okay, next question. Uniform line charge lambda is placed on an infinite straight wire, distance d above a grounded conducting plane. Let's say the wire runs parallel to the x-axis directly above it. The conducting plane is the xy plane. Find the potential in the region above the plane. Find the charge density sigma induced on the conducting plane. First, you read the question 2-3 times, then only try to solve it. Uniform line charge lambda is placed on an infinite straight wire. Distance d above a grounded conducting plane. Let's say the wire runs parallel to the x-axis directly above it, and conducting plane is xy plane. Find the potential in the region above the plane. Find the charge density sigma induced on the conducting. Just read the question. Okay. Yeah. Uniform line charge lambda is placed on infinite straight wire. Okay. Let's draw the diagram first. Okay. So here, see, I can draw the diagram also like this. Just wait. Find the potential in the region above the plane, right? Okay. So see here, the formula for it is what? Vyz, if you remember, Vyz, like y z axis, is 2 lambda by 4 pi epsilon naught. Okay. Ln s minus by s plus. Okay. So lambda by, I will take this 2 to here. Right, we can do that, right? So lambda by 4 pi epsilon naught ln s minus square by s plus square. Yeah. Yeah, that will be a potential only. Easy question. Hmm. Now, find the charge density sigma induced on the conducting plane. Okay, now see the charge density formula is what? Charge density is sigma is equal to minus epsilon naught del v by del n. Hmm. So what is here del v by del n? Del v by del n here is del v by del z. Okay, del v by del z. So sigma y will be how much? Minus epsilon naught lambda by 4 pi epsilon naught. Hmm. And you have to take the del v by del z. Whatever you got as v. Hmm. Okay, v I have to write it again. Suppose this one, no? V is equal to lambda by 4 pi epsilon naught ln s minus square by s plus square. If I write it, it will be what? Lambda by 4 pi epsilon naught ln s minus square is actually what? Y square plus z minus d whole square divided by y plus y square plus, this is z plus z minus d whole square. Okay. So sigma y del v by del z will be how much? Del v by del z, because we need it in sigma y. 1 lambda by 4 pi epsilon naught del by del z of ln y square plus z plus d whole square divided by y square plus z minus d whole square. Okay, epsilon naught lambda by 4 pi epsilon naught. Hmm. So if you take the derivative, you will get it. So lambda by 4 pi epsilon naught into y square plus z minus d whole square divided by y square plus z plus d whole square. And then the derivative of this one. Okay, y square plus z minus d whole square, and this minus this. Okay, I think you can calculate all this. After calculating all this, you will get the sigma y is equal to how much? Minus lambda d by pi y square plus d square. Okay, I'm leaving this up to you to calculate. I just gave you the idea. Hmm? So I hope you can calculate this. Okay, so this will be this for this class, and like this much, like 4 3 questions a day from Griffith also, man, like it will help you a lot. You don't need to do 10 15 questions a day, because that will ruin, like really overload your mind, you know. Okay, okay, then that's it for this class. We'll do more questions in the upcoming sessions. Thank you very much.